All right, in this lesson, we are going to talk about regression models. And so we're going to start with a warm-up over arithmetic and geometric sequences. And so given the sequence, identify the following. So in our first sequence, it is adding 4 each time. And so if we wanted to continue the pattern, we would just keep adding 4, and that would take us to 22, 26, 30. And so anytime you are adding, that is an arithmetic sequence. I remember because they both start with A. And so we call it a common difference. And in this case, our common difference is 4. That is the number we are adding each time. So for recursive form, we say we can get to any term by taking the previous term and adding 4. For explicit form, we start with the first term, which in this case is 6, and we add 4 to it n minus 1 more times. So if I was going to the 5th term, I would have a 4 here. If I was going to the 100th term, I would have a 99 here. Okay, this next sequence, we are multiplying by 3 to get our next term. So this is geometric, and we call it a common ratio. And so our common ratio here is 3. The recursive form would say we can get to any term by multiplying 3 by our previous term. And you could also put that 3 at the end. It just doesn't look as nice, but either notation would be correct. And then explicit is any term equals the first term, which here is a 2, times that 3, n minus 1 more time. So if I was trying to get to the 100th term, I would multiply by 3 99 more times. Okay, so for regression models, from given data, we want to analyze the change in x and y values to find a pattern, much like we do with sequences, that represents the data. The data could be given in multiple forms depending on the scenario. So we could have a table, we could have ordered pairs, and regression models only work with addition and multiplication. Okay, and so one thing to note is that subtraction is just adding a negative. Adding a negative number. So that's still addition. And then if we want to talk about division, that's just multiplying by a fraction. For example, if we were dividing by 2, that's multiplying by 1/2. Okay, and so when we are dealing with linear, that's our most familiar linear, you are going to notice the pattern you look for the x's is you want to be adding 1 each time. So every time you are identifying a pattern, you want to add 1 to your x's, kind of like a term number in a sequence. And then the pattern for the y is going to be adding whatever that common difference is. In that case, it's going to be linear. Okay, if you are adding 1 each time and your y's are multiplying by a common difference, that is going to be exponential. And then if you are adding 1 to the x's and you have a constant second difference, that is going to be quadratic. Okay, and so I'm going to show you what I mean by each of those. And so this is called regression because we can use calculators to give us the equation. And so a lot of the times we can do that very easily without a calculator, but if the data isn't perfectly linear, we want to get a best fit equation. And so in regression form, our linear equation y equals mx plus b. For exponential, it's y equals a times b to the x. And then for quadratic, it's ax squared plus bx plus c. And so when we're using Desmos, which is these notes talk about how to use a TI-84, but I want to show you how to use Desmos. You would type in y1. What you do is you just add ones to these variables. Ones to the y's and the x's, not the parameters, not the a's, the b's, and the c's, just the x's and the y's. And you change your equal signs to tildes. Okay, and so I'm going to write that at the top. And so if you are dealing with linear, you're going to put your table into Desmos, and you're going to do y1 tilde a x1 plus b. If you were dealing with exponential, you now have a times b to the x. So you're going to do y1 tilde a times b to the x1. Only x's and y's get the ones, not the a's and the b's. And then if you were dealing with quadratic, this is when you would do ax squared plus bx plus c. And so ax1 squared plus bx1 plus c. These ones in the subscript is just so you can refer to the table of points. That's how the calculator or Desmos knows what table you are referring to. Okay, so for each of these tables, we are going to identify the pattern to determine what the function is, and then we are going to use Desmos to write the equation if necessary. Okay, and so looking at number 1, each of our x's are going up by 1, and so our x's are adding 1. And then for our y's, we are adding 1. Okay, and so this is a linear function. And honestly, we don't need Desmos. I can see that my slope or my a value, change in y over change in x. My change in y is 1. My change in x is 1. And so my slope is 1. And then my y-intercept, which is my b value, is 4. And so I would write y equals 1x plus 4. And then often we leave that 1 invisible. If you were using Desmos, you are clicking the plus sign and choosing table, and then you are going to type your x's in the x column, and then you're going to type your y's in the y column. Okay, and so to get our equation, y1 tilde, and if you want to use a, you can. If you want to use m, you can. So y1, because notice in the table you see a y1 and an x1. So you're going to copy whatever that table says. y1, and then tilde a x1 plus b. Okay, and so they tell me a is 1 and b is 4, which is what we have written here. Okay, looking at this next example, it looks like my x's are going up by 1 each time. And my y's are multiplying by 3. Okay, so adding 1 and then times 3. And so this is an exponential function. Okay, and so we know we're looking for a times b to the x. And so for Desmos, y1 tilde, and then add the 1 to the x. But we know from our work with exponential functions that our a value is the y-intercept, and our b value is the common ratio. And so without using Desmos, we can write 9 times 3 to the x, a times b to the x. If you're using Desmos, clear everything out so you have a fresh table, and then type your table in. So -2, -1, 0, 1, 2, and then 1, 3, 9, 27, 81. So now I'm typing the tilde equation. It's exponential, so y1 tilde a, and then I like to just do the time sign. You could do parentheses if you wanted to, times b raised to the x1. Okay, and so here they tell me a is 9, b is 3, which we were able to gather before we even typed it in. All right, looking at number 3, my x's are going up by 1 each time. And my y's, it looks like we added 6, and then we added 8, and then we added 10, and then we added 12. Okay, and so obviously it's not multiplying by the common number, it's not adding, but if I go to my second difference, the second difference is the difference of the differences. So from 6 to 8, we've added 2. From 8 to 10, we've added 2. And from 10 to 12, we've added 2. Okay, and so in the x's, we're adding 1, and in the y's, we have a common second difference, which is 2. And so this is a quadratic function. And we don't have an easy way to write the quadratic equation from these points. So that's where Desmos is going to be really helpful. We want ax squared plus bx plus c. So when you type this in Desmos, you put 1s on the y's and the x's, and you change your equal sign to a tilde. Okay, this works for any function type. Okay, and so clear your table, get a fresh start, plus sign, table, type your x's, type your y's, and then y1 tilde a x1 squared plus b x1 plus c. So just adding 1s to your x and y, so we're referring to the table and using a tilde. So here I see a is 1, b is 5, and c is -6. So y equals 1x squared, which we leave the 1 invisible, plus 5x minus 6. Since a is 1, b is 5, and c is -6. Okay, looking at number 4, my x's are going up by 1. And my y's, from 22 to 16, that's subtracting 6, subtracting 4, subtracting 2, subtracting 0. Okay, and so obviously not adding a constant number, but if we go to our second differences, the difference of the difference, we added 2 to get from -6 to 4. We added 2 to get from -4 to -2. We added 2 to get to 0. So we have a constant second difference. So x's are going up by 1, In the y's, we have a common second difference of 2. And so that doesn't help us write the equation, but at least now we know it's quadratic, and we know we want our ax squared plus bx plus c. And so when we're using Desmos, we know just to put ones with your y and x and change your equal sign to a tilde. Okay, and so clear everything, get a fresh table so that it says x1 and y1 at the top, and then -4, -3, -2, -1, 0, 22, 16, 12, 10, 10. Okay, new line, y1, tilde, a, x, 1 squared plus b, x1 plus c. So here I see a is 1 and b is 1. And c is 10. And so my function rule, y equals x squared plus x, leaving the ones invisible, plus 10. Okay, here they're giving us ordered pairs, and so my advice is to write these ordered pairs in table form so that we can use what we've been doing in the previous examples. So my first point is 0, 8, and then I have 1, 3, and then 2, -4, and then 3, -13, 4, -24, 5, -37. Okay, and so my x's are going up by 1. And then my y's, it looks like we've subtracted 5. And then we've subtracted 7. And then we subtracted 9. And then we subtracted 11. And then we subtracted 13. So going to our second difference, from -5 to -7 is -2. -7 to -9 is -2. -9 to -11 is -2. -11 to -13 is -2. Okay, and so we are adding 1 in the x's, and we have a constant second difference of -2. That doesn't help us write our quadratic equation, but we know it's quadratic. And so we know we are going to have ax squared plus bx plus c. And so after we enter our table, we are going to put tildes and ones with our x and y. Okay, and so now we already have our table written, so that makes it easier to enter into the calculator. It's important to clear everything each time, otherwise it may not say x1 and y1 at the top of your table. Okay, and so 0, 1, 2, 3, 4, 5. And then we have 8, 3, -4, -13, -24, and -37. Something else that is cool about Desmos is it graphs it for you as you're plotting it. It's not a good picture because we don't have the full picture of the quadratic, but after we get our equation, y1 tilde a x 1 squared plus b x1 plus c, you can see that our quadratic does go through those points. You may have been noticing that throughout, but I didn't point it out. Okay, and so I can see that my a value is -1. My b value is -4. And my c value is +8. So when I write my equation, I would say -x squared minus 4x, and then plus 8. Okay, for this next example, we have points again, so put it in a table. It's easier to analyze patterns with a table. Okay, so my first point is 0, -5, 1, -2, 2, 3, 3, 10, 4, 19, and 5, 30. My x's are going up by 1 each time, so we know we can look at a pattern. And then looking at the y's, from -5 to -2 is adding 3, then we are adding 1, then we are adding 7, and then we are adding 9. Oh, we're not adding 1, we are adding 5. And then we are adding 11. And so we can look at our second difference, which is adding 2 each time. Okay, and so once again, this is quadratic because we have a second difference that is constant. And so our function type we know is quadratic. And so we know we are looking for ax squared plus bx plus c. Add ones to your x and y, and then change your equal sign to a tilde. Okay, and so when you enter this into Desmos, clear everything. Don't keep this stuff. Otherwise, you're not going to have x1 and y1. And so plus sign, table. Copy our table in here, 0, 1, 2, and it starts noticing what you're doing if it goes by ones. And then -5, -2, 3, 10, 19, 30. Okay, that's still looking kind of quadratic. It's making that curve. So getting our equation, y1 tilde ax1 squared plus bx1 plus c. And so we can see that a is 1, b is 2, and c is -5. Seems like it's a lot of steps for this, but this is actually saving you a whole lot of work. And so y equals x squared plus 2x minus 5. Okay, for this last one, it says it's a application problem dealing with fractals. The table shows the number of new branches in each figure of the pattern. What is a pattern you can use to complete the table? Represent the relationship using words and an equation. Okay, so here our x value is 1, and we have 3 branches. And then each of those 3 branches has 3 branches. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if we were to count each of these, we would have 27. And so it's multiplying by 3 in the y's. Okay, and so while our x's are going up by 1s, that is what helps us identify that we're multiplying by 3. That means this is exponential. Okay, and here we don't have the y-intercept, but we do have the b value. And so a we're not sure of, but b we know is 3. So this is going to be y equals some value times 3 to the x. And so if we were to go backwards, we would just divide by 3, and that would give us a 1. And so y equals 1 times 3 to the x, which they're going to leave it pretty simple and just rewrite it as y equals 3 to the x as your equation. Okay, if you're going to Desmos, they would tell you a equals 1 and b equals 3.